Okay, so there's 5 formulas that we consistently use. They basically all start from the A equals change in velocity over change in time. So your acceleration is your change in velocity over change in time. That's kind of where they all start at. Okay, so this one comes from that equation. V2 is equal to V1 plus A delta. You don't have to write this down. I just want you to follow. Okay, so I've got A delta T. So again, I'm going to give you 5 formulas in which you'll be given 3 pieces of the 4 pieces of information for all of them in order to figure out what to use. Okay, the one we use a lot is this one. Okay, and that's finding your distance given that you know the initial velocity, the time in which you are accelerating at. So we use that one more than most. The one I would say we use the rarest would be this one. And again, I'm sure in grade 11 physics, Ms. Zhang showed you where they come from. They come from a graph, and then you find each of these equations from the graph. I don't need you to know where they come from. I need you to be able to apply them. This one is used a lot because if there's no time for it, you use this guy all the time. All right, this is the one you use every single opportunity in which you are not given time. It's the only one of these equations that you're not given time. The other one that we don't use a lot of is this velocity average one, but it's on there as your 5th one. Okay, so that's velocity average times time, but we don't use that very much because usually when we talk about velocity, we talk about acceleration. So you'll notice, okay, so let's just pick out the differences that we know. D here. This one we have what? Everything actually, right? There's no V2. No V2 in this guy. That's basically it. This one, no V1 in. This one, no time in. This one is no acceleration. Okay, so those are the ones that we're going to primarily focus on. So now, and we're going to use these often in the next section, but I'm going to show you how to solve these things, solve the questions without the use of these, using energy laws instead. They're a lot simpler than these, but I'm also going to use these to prove that we got the energy parts right. So it's projectile motion. You asked about that. We're going to do a little bit of projectile motion, but we're using it in terms of work and energy rather than the dynamic equations. Okay, so just looking at that 16 then. You have a 200 kilogram shot is discharged horizontally from a cannon of mass 2 times 10 to the 4th kilograms with a speed of 250 meters per second relative to the ground. Find the steady force which, acting on the cannon, will stop its recoil in 2 seconds. Okay, so we begin with the momentum aspect of this question. So this is what I have here. Okay, what is the momentum before the cannon is shot? 0. Nothing's moving, correct? So I have 0 kilograms meters per second here. Then over here I have mass 1. What's the mass of the cannon of the ball? 200 kg, right? And then it moves at 250 meters per second. Prime, and then that's added to 2 times 10 to the 4th is the mass of the cannon itself, kg, and then velocity prime. All right, so even if you don't understand how to manipulate equations with, like, or you're not strong at it in terms of algebraically, plug in the numbers. Now, what is the one thing I got to find here, obviously? I got to find V prime. And what does V prime represent in this question?
Velocity after.
Right, it represents the velocity of what after? The cannon itself. Okay, now thinking about the gun question that we did earlier this week. the gun fires out one way. Which way does the gun itself go after? Backwards. It recoils. The same thing happens with this cannon. So I probably, because I've designated 250 meters per second as a positive, I should end up with a negative value here. Okay, 200 times 250 divided by 2 times 10 to the fourth. What do you get? I'm asking for the answer here. Just the speed. I just want the speed of the cannon going backwards.
2.5.
What is it?
It's 2.5.
2.5 meters per second is your V prime. Okay, so I'm not answering the question itself yet. I'm just getting to this point. Okay? Are we all right so far? Yes? We follow? Okay. Now, impulse. Impulse is force times time. And it's equal to the change in momentum. The change in momentum is m2 v2 minus m1 v. Sorry, there's no actual. The mass is the same for both of these. So it's mv2 mv2 subtract mv1. Okay. We good so far? All right. We want to know the amount of force acting on it over how long? 2 seconds? Equals the mass, which is 2 times 10 to the fourth kg. My V2 is negative 2.5 meters per second. Subtract my mass, which is 2 times 10 to the fourth times 0. My initial velocity of the cannon was 0, right? Yeah? I need you guys to help a little bit here, okay? All right, so let's find the force then. Now, remember, it's a stopping force. So if it's a stopping force, that means it has to be working against the cannon itself. It should have a negative Newton value to it. So what's 2 times 10 to the fourth times 2.5 divided by 2 seconds? Negative 25,000 newtons. That means that it's going to slow it down with a force of negative 25,000 newtons. Good so far. All right. Now, one thing we didn't talk about on the initial board. This is another one here. F net equals mass times acceleration. F net equals mass times acceleration. Okay? All right. Now, the next part of this asks for how far will the cannon recoil? I need a distance. All right? So in order to get a distance, let me do this on the second page. In order to get a distance. So this is what I do every time. Now you can do this if you like. You don't have to do this, but I try and do this every time and fill in the blanks so then when I'm looking at my formula sheet, I can see which equation I need based on all of the information that I've got. So what I do is I do this. V1, V2, A, D, delta, T. So that's what I have here. So then I start to fill in information. Now, I'm looking for the distance of the recoil. Do I know the initial velocity of the cannon itself? Initial velocity. Okay. Now, here's the catch. I am only talking about after it fired. So after it fired, what's the initial velocity of the cannon? 2.5, right here. It's 2.5 meters per second. Now, I don't need the direction aspect of this right yet. Okay? So this is 2.5 meters per second. That's how fast it starts at. And then what happens to it? It it stops. So therefore my V2 is what? 0. Okay, so far so good. Now I need either an acceleration or a time from the initial part of the question. Okay, now here's the catch. Yeah. All right, I wouldn't have done it that way. I didn't do it that way with you yesterday, for the record. But I'm going to do it this way, and then I want to see if I can make this work, okay? All right, so there I have it. I have V1, I have V2, I need D, and I got time. Well, I just said I don't use this equation ever, but I'm going to use it.
You should just find out the acceleration.
Okay, that's what I would have done to start with. I wouldn't have used the 2 seconds. But let me solve it this way, see if I get the same answer as if I get the acceleration.
We have the, you gave me the acceleration.
We found the acceleration.
Yeah. Oh, you're
Okay.
doing it the other, okay.
So the acceleration is found like this. Minus 25,000 newtons is equal to the mass of the cannon. No, I got, no, that's right. Force equals mass times acceleration. So take your 25,000 and divide it by 2 times 10 to the 4th, and what do you get? Sorry?
Negative 1.
There's my acceleration. So I put that in here. Negative 1.25 meters per second squared. Okay, I'm going to work this question through first as if I didn't have that time, using that. So which equation deals with V1, V2, A, and D? The only one that doesn't have time is which equation?
V2 squared equals V1 squared plus 2.
I don't know of an easier way to show you this than to list those out and then look at the equations that are given to you and say, okay, I have 4 pieces of information. I need those 4 to be all in the same equation. Okay? So now, V2 squared is 0. V1 squared is 2.5. It could be a negative, but I'll put a square there, so it doesn't much matter. 2. This is a negative. And D here. Okay, what is 2.5 squared?
6.25.
6.25. And then I'm going to subtract that over to the other side here. All right? And then I got to divide by that, which is minus 2.5. So 6.25 divided by minus 2.5 is what? Sorry?
2.5. Negative 2.5.
No, positive.
Or no,
2.5
positive. Yeah.
meters. So it went 2.5 meters. Okay? That's a combination right now of your momentum with your dynamics. All right, we're going to do a fair bit of that.
But shouldn't it be negative since you're going in a big one? You're going back.
I'm going to say no. Distance. Okay, now that's a tricky question. Distance in theory has to be an absolute value because it's different. But we are talking displacement, so theoretically you could have a negative on there, which would just tell you that the direction was negative. However, when you actually solve this the way I've solved it, this becomes positive here, right? And then I subtract it to that side, so it's negative 6.25. This is negative here because of the deceleration. So when I divide a negative by a negative, I actually get the positive value. Okay, so it is at 2.5 meters. It's positive because I'm only focused on the change of direction of the cannon itself. I didn't say that the cannon's initial direction was right positive because it was stationary.
So it's like I used a different formula and I got a negative. So is that
Okay,
wrong
so
then?
let's try it. You used with the one with time, correct?
Yeah.
Okay, so you had delta D equals,
V2. I'd like V2 delta T minus 1/2.
Okay, I'm gonna check this. You use this guy?
Yeah.
Okay, let's see if you've got this right. So this is 0, right?
Yeah.
Then I get a -1/2, right? But my acceleration is a negative.
Oh, so then when you multiply it together, it'll be plus one.
Right.
And then-
Did you end up with the same value though? Did you end up with 2.5? Yeah. So I could have done it that way as well. Now that's the thing. You can use all of these equations and get it. You just might have to solve to find one extra piece. And if you can do that, then that's great. There's no just one way of doing it. Okay? So let me look at 18 next. When a person parachutes, the impact velocity is equal to that attained in a free fall from a height of 4.5 meters. After contacting the ground, the jumper's momentum is quickly brought to 0 by the earth. What is the impact velocity? Okay, so impact velocity. Again, let's start like this. And let's put in what I know and what I don't. All right. The impact velocity is equivalent to me standing on something 4.5 meters high and dropping off of it and hitting the ground. What is my initial velocity? My initial velocity is 0. I'm not moving at the top of this. It's basically the same as me standing on the top of a diving board and just dropping. Okay? I'm looking for V2. So I'll put the question mark right here. My A, what is my acceleration? Okay, there's the first thing I want to contradict. I told you at the start of the week, and this is so very important, I said, generally speaking, we say up is positive, down is negative, correct? But I said I don't like that in certain cases. This is one of those cases. Because if I make it negative, when I talk about acceleration being negative, right? That means I'm slowing down, doesn't it? If I have a negative acceleration, that means I'm decelerating, which means I'm slowing down. But is that what I'm doing when I fall? No. So I'm going to make acceleration positive when it's increasing my speed. Hence, anytime I am going down, free falling, whatever it may be, throwing a rock, it's falling down. When it's going downwards, it's going to be gaining speed, which therefore I think I should treat it as positive. So I'm not going to put a negative on this. I'm going to put in positive 9.8 meters per second squared. Okay? And how high up was it?
4.5 meters.
4.5 meters. All right. Now looking at that then. I've got V1, I've got V2, I've got A, I've got D, but I don't have, I have V1, A, D, I need V2. Which equation deals with those four?
V2 squared.
V2 squared equals V1 squared plus 2AD. Beautiful. Put in your numbers if you like. What is your impact velocity here? What did you get?
9.39.
9.391 meters per second. Okay. Everybody agrees with that? Madison, you did not get that value?
I got a negative, but I'm trying to figure out why I got it.
Because you put, I talked to you about this yesterday, you put that as a negative. I don't want that as a negative.
I didn't write it down as a negative.
Okay. Well, there's nothing else you can do.
Oh, never mind. Okay. I just wrote it down, but I actually took it.
Okay. We're good so far. That's the impact velocity when you hit the ground. It says the impulse of the ground on the jumper assuming, what is the impulse assuming a mass of 80 kg? Okay. Now sometimes we have to look at questions in stages. and treat the stages a little bit different. So the first stage was I dropped from a free fall from V1 down to the ground. Now, the moment I hit the ground, okay, my velocity that I hit the ground at goes from 9.39 meters per second to 0, right? It stops me suddenly. Okay, so the question says, what is the impulse of the ground on the jumper? So impulse, force times time, is equal to mv2 minus mv1. Well, what's my v2 in this case now? I've hit the ground, and then what happens to me?
You stop.
I stop. So what's my v2?
Zero.
0. Okay, so my impulse, force times time, is equal to 0 minus my mass is 80 kg times 9.391 meters per second. My impulse is what?
751.28.
751.28. What are the units on impulse?
Meters per second.
Not per.
Or time second.
Yeah, just Newton seconds. Yeah. All right. Now that's still the same as kilograms meters per second, really. But because I'm talking about impulse, I can just convert those. I can just change them to Newton seconds. Good so far? And then the last part of that question says the average force on the jumper's feet if he lands stiff-legged and the impulse only lasts 0.019 seconds. So all I have to do is do what? Divide. Divide that number by 0.019 seconds and then 0.005 seconds in the second part. Okay? What I want to point out is that these stages were treated differently because this was my V2 in the first stage. My second stage, that was my V1. It changes based on what part of the question you're in. All right? Okay. All right, that was all I wanted to look at. But is there anything else you want to see? 22. A toy rocket develops an average force thrust of 4 newtons when the velocity of the exhaust gases relative to the engine is 30 meters per second. Calculate the mass of gases ejected per second. I hate these force thrust questions, but I'll try. I'll see if I can get it with you. Okay, so it has a force of 4 newtons. And the velocity of the exhaust gases relative to the engine is 30 meters per second. Time is 1 second. Okay. That's the part I think you would have missed. The 1 second. Because it asks for per second. So you put the time down as 1 second. Now I'm using impulse equals momentum. And one of my momentums is 0. So all I have basically is Ft equals mv. Okay?
Yeah.
Try that and see how you make out with it. Basically what it comes down to, I think, is 30 divided by 4 divided by 30 or 30 divided by 4, one or the other. But let me make sure. I don't want to leave you straight here. Yeah, 4 divided by 30. Okay? they essentially get this. Maybe trying to find out what M is. All right. Anybody else want to look at anything? The book is not the easiest to follow for the answers either. You have to kind of piece it together, I find. The explanations aren't ideal. Okay. If you're okay, I'll finish there. And then if you have questions, just bring them here and let's look at them. All right.